Welcome back to the channel of Chem Pacific, and now we are going to discuss about the second part of the video. The first part I've already discussed in lecture number 3 in our previous video. Please go and check it out. Link I'll definitely put it in the description box. And also please do subscribe our channel and hit the bell notification. So now let us solve this question. This is CSIR-NET December 2015 part B question, and they're asking for the metal-metal bond order, which means the number of metal-metal bonds in this complex. This is a very easy complex, and now what we need to do is let us a bit discuss about what is the role of this mu Cl and how is it 3-electron donor. See, the electronic configuration of chlorine is 3s2 3p5. So when it is in the bridged form, definitely it is getting bonded to two metals, right? So when it is in the bridged form, it is getting bonded to two metals. So it is having electronic configuration 3s2 3p5. So when it is in the bridged form, you see it can actually result in the formation of coordinate covalent bond with metal 1, and it will result in the formation of a single normal covalent bond with the metal 2. So total यहाँ पे हो गया 2, यहाँ पे हो गया 1. That is why mu Cl is nothing but 3-electron donor. And therefore now let us add the electrons of this complex. Let us do the total electron count. So tungsten is having the valence electron 6, and this is in the eta 5 mode. So this is 5, and Cl, mu Cl in the bridged Cl is 3-electron donor. Just now I discussed how it is 3-electron donor, and we know that CO is 2-electron donor, and you are having 2 CO. Since it is a dimer, you have to multiply with 2. So therefore overall it will result in 14 plus 4 into 2, which is equal to 18 into 2. It means it is 36. Since you're having two metals, so 36 electron count means this complex is a stable complex without the formation of any metal-metal bond. Therefore, this complex is having 0 metal-metal bond. So now this is CSIR-NET June 2015 Part C question, and they are asking for the binding modes of Nitrosyl in these two complexes. So before I solve this question, I would like to discuss in detail about the Nitrosyl. Since Nitrosyl, there are two Nitrosyl, one is linear and bent, and how are they formed and how much electron donor they are going to be, that's what I'm going to discuss now. See, nitrogen is having electronic configuration 2s2 2p3. So once it results in the formation of NO, obviously you know this is very easy, that when it forms NO, so it will result in the formation of one sigma bond with oxygen and also one pi bond. Right. So now it is clearly visible to all of you that this nitrosyl is actually having one unpaired electron. That is why this nitrosyl can actually act in two different ways. It can either give out its one electron and result in the formation of NO+, and when it is NO+, it is named as linear nitrosyl, or else it can also accept one electron and result in the formation of NO-. So when it is NO-, it is defined as bent nitrosyl. Now see students, so we have to now see how is this linear nitrosyl 3-electron donor. First of all, let us discuss about the linear nitrosyl. Now see students, what happens, this nitrosyl first gives out one electron to a metal and resulting in the formation of NO+. So what happens, this electron which was actually given by linear nitrosyl, this electron is now accepted by the metal, resulting in the formation of M minus, and later on this M minus results in the formation of coordinate covalent bond with NO plus. Now see students, क्या हुआ, पहले इसने मेटल को एक इलेक्ट्रॉन दिया resulting in the formation of M minus, बाद में इसने 2 इलेक्ट्रॉन दिया for the formation of coordinate covalent bond. So total इसने कितना इलेक्ट्रॉन दिया, यहाँ पे 1 दिया, यहाँ पे 2 दिया. So इसने दिया 1 plus 2, इसने दिया total 3 electrons. That is why linear nitrosyl is 3 electron donor. Now let us discuss about the bent nitrosyl. Now this bent nitrosyl जो है, this is NO minus. So bent nitrosyl कैसे बनते हैं? So एक metal, it actually results in the formation of M plus and it gives out 1 electron. This electron is accepted by NO and resulting in the formation of NO minus. Later on, one coordinate covalent bond is formed between M plus and NO minus. Now see students, पहले क्या हुआ, पहले इसने एक इलेक्ट्रॉन मेटल से लिया, बाद में इसने मेटल को 2 इलेक्ट्रॉन दिया, राइट. सो पहले क्या हुआ, एक इलेक्ट्रॉन लिया और बाद में इसने मेटल को 2 इलेक्ट्रॉन दिए. सो देयरफॉर पहले क्या किए थे, एक लिए थे, ठीक है, बाद में इसने 2 दिए, तो टोटल कितना दिया, टोटल इसने 1 इलेक्ट्रॉन दिया. दैट इज व्हाई दिस बेंट नाइट्रोसिल इज 1 electron donor. Clear? So now I hope this is very much clear to all of you how the linear nitrosyl acts as a 3 electron donor and bent nitrosyl acts as 1 electron donor. Now let us solve this question. Now let us name this complex as 1 and this complex as 2 and then do the total electron count. Now the TEC of total electron count. Now this cobalt is having the valence electron 9. ठीक है, तो उन्होंने कहा बोथ द कॉम्प्लेक्सेस आर 18 इलेक्ट्रॉन. हमें एक्चुअली फाइंड आउट करना है इसका नेचर क्या है, लीनियर है और बेंट है. सो कोबाल्ट जो है इन दिस कॉम्प्लेक्स 1, कोबाल्ट इज हैविंग द वैलेंस इलेक्ट्रॉन 9 एंड यू आर हैविंग 3 CO. सो 3 into 2 plus x, we don't know ये कितने इलेक्ट्रॉन डोनेट कर रहा है, वी हैव टू फाइंड इट आउट. सो दिस इज इक्वल टू 18. देयरफॉर x is equal to 18 minus 15. So in this case, x is equal to 3 electron donor. So when it is 3 electron donor, it has to be linear. Clear? Now let us solve the second one. Second one, you see, nickel जो है, nickel is what having the valence electron 10 and this is in the eta 5 mode. So it is eta 5 mode, so we have to add plus 5 plus again x. Plus x, that's what we have to find out, is equal to 18 and again x is equal to 18 minus 15 which is equal to 3. So since it is again 3 electron donor, again the answer is linear. So in this case both the complexes are linear and linear, so the answer is 3. Now let us move on to the next question, CSIR-NET June 2014 part B. And they are asking for the oxidation state of nickel. They're asking for the oxidation state and of nickel and also the number of the metal-metal bonds in this complex. Now say students, this is very easy, the oxidation state, because we know that carbonyl is a neutral ligand, and as if it's a neutral ligand, therefore this charge is residing on a metal, and since you are having -2 charge for 2 metals, and therefore what is happening, and therefore you are having 2 into -1. Therefore the oxidation state of 1 nickel is -1. Very easy. And now let us solve this. Now say students, you're having 2 nickel. Let us do the TEC, total electron count. Nickel is having valence electron 10 plus a CO, you are having 6. So 6 into 2, and due to the charge you have to add plus 2. So it will turn out to be 20 plus 12 plus 2, which is equal to 34. And now you know that if you are having two metals, so total electron count कितना होना चाहिए, 18 into 2 होना चाहिए, which has to be 36 होना चाहिए था, but आपका कितना हुआ 34. So कितना आपका remaining है 2 electrons. So 2 electrons, it results in the formation of one metal-metal bond. Very easy. And henceforth the answer is C. Nickel is having oxidation state -1 and it is having one metal-metal bond. I hope this is clear to all of you. Now let us move on to the next question. This is CSIR-NET December 2011 part B. Now the correct combination of the metal carbonyls of this carbonyl complex. Now this carbonyl complex they are asking. Okay, so say student, for this all you have to do is, so you have to apply the formula like metal का क्या valence electron से. If you, for example, if you take the example A, so what you have to do is you are having metal का क्या valence electron, so that we have to do, and then carbonyl is 2 electron donor and you are having X, and since it is Z minus, so we have to add plus Z, and this has to be equal to 18. So we have to A के लिए क्या हो रहा है? In the case of A, so titanium is having valence electron for in the case of A. ठीक है? They have given titanium. So titanium is having valence electron 4 plus 2x. So 2 into x, what they have given? They are given 6. So this is having 6 and Z they have given you 1. तो कितना हो गया आपका? This will turn out to be 4 plus 12 plus 1, which is equal to 17 electron. So ये 18 electron ओबे नहीं हो रहा है, so this is not going to be the answer. What about the B? B is having vanadium, so vanadium is having valence electron 5, and they have given you the information X is equal to 6. So what you have to do? 2 into 6 plus charge they have given you 1. So 2 into 6 plus 1. So this is equal to 5 plus 12 plus 1. Yes, this is 18 electrons. So we don't have to calculate because we got our answer already. The answer is B. Clear, students? Now let us move on to the next question, and again they're asking for the number of metal-metal bonds in the dimer. So in this case you see that they have not informed whether the nitrosyl is linear or bent. Whenever this kind of situation arises, you have to consider the nitrosyl to be linear only, and we know the linear nitrosyl is always 3 electron donor. Now let us take the example of example 1. So you have the CP eta 5 mode, and iron is having the valence electron 8 and carbonyl is 2 electron donor, and I already informed you that whenever they have not specifically mentioned that whether this nitrosyl is linear or bent, then you have to consider it as linear nitrosyl only, and linear nitrosyl is always 3 electron donor, which I have discussed in detail. So you have to consider this as linear only, and we know linear is always 3 electron donor. Okay, and you are having, this is a dimer, so what you need to do is you have to multiply with 2. So overall it will turn out to be how much? This will turn out to be 18 into 2, which is equal to 36. So therefore, since it is 18, this is stable without metal-metal bond, and therefore number of metal-metal bond is 0. Now let us move on to the second example. This. So let us inform it as 2. So again you have this CP. So when you are having this CP, so therefore what you need to do is Cp, it is in the eta 5 mode, and this molybdenum, इसका valence electron क्या है 6, and they have given you carbonyl, 3 carbonyl, and each is 2 electron donor, right? And since it is a dimer, how do you know? Because here it is 2, you have to multiply with 2. So this is equal to, so this 11, this is 11 plus 6, this is equal to 17 into 2. So this is equal to 34. So when it is 34, what is going to be? This is 36 minus 34, which is equal to 2 electron, and 2 electron results in the formation of 1 metal-metal bond. So the answer is 0 and 1. So the answer is D, which is 0 and 1. Clear? Now let us move on. Here I have completed all the questions that are from the topic of 18 electron rule. So this is I have completed, and the last but not the least, what I would like to discuss with you is the difference between the neutral method and the oxidation method. And this is the last portion, and neutral there. So I already informed you that while calculating the 18 electron rule, there are two methods. One is the neutral method and another is the oxidation method. So neutral method jo hai, this is very much convenient and it results in less mistakes. So we always follow the neutral method, but you must know what we mean by oxidation method. See students, in the case of the neutral method, what happens? What happens, यहाँ पे जो प्लैटिनम है, ये जो प्लैटिनम है, इसका जो वैलेंस इलेक्ट्रॉन हमसे वही काउंट करता है, एंड वी कंसीडर इज अ न्यूट्रल लिगैंड. अगेन क्लोरीन जो है इसका भी एज बिकॉज न्यूट्रल स्टेट में ही हम करते हैं, और इन दिस केस जो आपका चार्ज रहते हैं वो न्यूट्रल मेथड में हम हमेशा, अगर वो नेगेटिव चार्ज है, वो न्यूट्रल मेथड में हम हमेशा उसे ऐड करते हैं. Right, so since we know that platinum is having valence electrons what 10, so we are usually यहाँ पे 10 ऐड कर रहे हैं. Now in neutral method I already discussed you, जो वो terminal Cl है, this is one electron donor. So how many you are having? You are having 4. So 4 into 1, and the charge, since it is negative charge, we have to add this charge. So it will turn out to be 16, and since it is a square planar complex, this is definitely obey 16 electron rule, and I have beautifully explained with you that what do we mean by 16 electron rule, what is 18 electron rule, and when the complexes obey octet rule. That I have already beautifully explained in my lecture number 1, and do watch it out so it will become more clear to you. Now whenever हम ऑक्सीडेशन स्टेट कर रहे हैं, so उस टाइम हम क्या करते हैं, बहुत अच्छे से देखो स्टूडेंट्स. नाउ जब यहाँ पे हम ऑक्सीडेशन मेथड कर रहे हैं, so Cl we are going to consider this as anionic ligand, and we know that Cl is an anionic ligand. तो इसका जो चार्ज है, इसका चार्ज कितना है, -1. तो कितना Cl ligand है आपके पास है 4, so -1 into 4. And now what is X? X is the oxidation state of the metal. So you are having 4 Cl ligand, and each is having charge -1, and overall this is equal to -2. Therefore overall the charge is -2. Therefore X का oxidation state कितना हो गया, X का हो गया 4 - 2, this is equal to +2. That is why यहाँ पे इन लोगों ने यहाँ पे जो platinum है इसका oxidation state हम +2. So we are actually considering metal in its oxidation states, hence for the name derived is oxidation method. So when it is +2, see students, इसका valence electron कितना था, इसका valence electron था 10. So जब वो +2 हो जाएगा तो फिर क्या हो जाएंगे, तो इसका valence electron 2 इलेक्ट्रॉन कम हो जाएगा, है ना. So इसके valence electron हो जाएंगे 8. Now see students, जब ये neutral था, it was actually, when it was neutral, it was actually 1 electron donor, right? So when it turns out to be Cl minus, therefore कितना Cl minus है 4, and when it turns out to be Cl minus, it will turn out to be 2 electron donor, right? So when it turns out to be Cl minus, it will turn out to be 2 electron donor. So that is why we are multiplying here with 2. So Cl minus in the oxidation method is 2 electron donor. तो ऑलरेडी हमने यहाँ पे चार्ज कंसिडर किया ही है, ठीक है। एंड सिंस मैंने यहाँ पे क्लोरीन का -1 लिया है, इसीलिए आपका X बन गया प्लैटिनम का +2. सो वी हैव ऑलरेडी solved it by considering the charge itself. So at the end you don't have to add the charge like we actually did in the neutral method. तो यहाँ पे oxidation method में always remember, since हमने charge को consider करके ही metal का and ligand का जो चार्ज हमने बिठाया, तो हम यहाँ पे ये चार्ज को कंसिडर नहीं करेंगे क्योंकि ऑलरेडी हमने किया है। तो ओवरऑल जब आप ये सब ऐड करते हो, ये भी 16, तो ऑब्वियसली 16 ही होगा क्योंकि दोनों का तो सेम है, वो 16 है, दैट इज ऑब्वियसली सेम। बट इम्पॉर्टेंट ये है हम कैलकुलेट कैसे करते हैं। तो बेसिकली ऑक्सीडेशन मेथड में स्टूडेंट्स क्या करते हैं कि यहाँ पे चार्ज लेने के बाद फिर से चार्ज करके, क्योंकि न्यूट्रल मेथड करके वो हैबिट हो जाता है। सो कीप इट इन योर माइंड, इफ यू आर फॉलोइंग ऑक्सीडेशन मेथड you don't have to consider the charge at the end. यहाँ पे at the end don't consider the charge, don't subtract or add the charge. This is the basic difference between the oxidation method and the neutral method. And this is the end of the video, and please do like, share and subscribe. Thank you.